Hello, and welcome to the session on time and work. This is the first part of the session. You can provide your feedback via Twitter at my Twitter handle @Ravi Handa. To begin with, the most important idea, in my opinion, in this chapter is work rate into time is the amount of work done. Now, I'm sure you'll know what time is and what work done means. But what is the work rate? Let's say if you can do a particular task in 5 days, then your work rate is one fifth of the work per day or 20% of the work per day. Let's say that you work for 3 days, then you would have done 3/5 of the work or 60% of the work. Please note that whenever you get a question which is related to payments, the payments are always directly proportional to the amount of work done. They do not depend upon what was your efficiency, they do not depend upon for how long you worked. The bottom line matters. And the bottom line is that whatever is the work that you actually did, your payments will be proportional to it. Another concept which comes in the case of work and time is efficiency. Now, what is efficiency? In the concept of efficiency, you need to understand that different people can have different work rates. Let's say if you can do a particular task in 2 days and I can do that same task in 4 days, then who is more efficient? You are more efficient because you can do the task in just 2 days, and that, my friends, is efficiency. You are double, you have double the efficiency of what I do. In similar cases comes the concept of work equivalence. Continuing with the same example, let's say that you are double my efficiency, that would mean it will take two people of my type to work as much as you do. And this can be used in a few questions. Another concept which comes in is of negative work. Well, you might be wondering, if everyone is working, how can there be a concept of negative work? Well, negative work comes in case of pipes and cisterns, such as inlets and outlets. Let's say if you are trying to fill a tank or a cistern, then inlet, since it is filling, is doing positive work, whereas the outlet, since it is taking out, is doing negative work. Very similarly, if your task is to empty a cistern or a tank, then your inlet is doing negative work, whereas your outlet is doing positive work because your task is to empty the tank. Well, we look at a few problems and a few ideas on how to solve all these questions in the next video. Thank you. This is the second video on time and work. You can provide feedback via Twitter at my Twitter handle @Ravi Handa. In this particular session, we'll try out some actual problems, some actual formulas. In the last video, we just introduced the basic concepts. Well, we'll see what happens when two people are doing the same work. We will also look at the formula for when three people are doing the same work. But before we even start off with that, one very important thing that we need to understand is the concept of work rate. Let's say A does a certain amount of work in A hours. That means that in 1 hour, A would do how much? A would do 1/8 of the total work. Let's say A finishes a particular task in 12 hours. So in 1 hour, it would do 1/12 of the total amount of work. If you understand that, that is the key concept of work rate, then let us look at this. Say A does a particular job in A hours, B does the same job in B hours, then together how much time will they take? If you think it is A plus B, you are wrong. Together they will take AB by A plus B hours. It is also very important to understand how we got this formula. Well, A does the job in A hours. In 1 hour, how much will A do? A will do 1 by 8th of the total amount of work. In 1 hour, how much will B do? B will do 1 by bth amount of the total work. So, total work done in 1 hour is how much? A does 1 by A, B does 1 by B. So, total amount of work done in 1 hour is A plus B by AB. And if this is the total amount of work done in 1 hour, time taken to finish the work will be reciprocal of this value, which will be AB by A plus B hours. If you didn't understand this, let's say if together while they were working they did 3/5 of the work in 1 hour, then how much time will they take to finish it? They will take 5 by 3 hours to finish the task. Looking at another case of this, let's say A does a particular job in A hours more than A and B combined. So I'm not saying that A does a particular job in A hours. I'm saying whatever time A and B combined took to do it, A takes A hours more than that, B takes B hours more than A and B combined, then together they will take root AB hours to finish the job. This is also a very important formula, but it is equally important to understand how this came. Let's say that A and B combined can do the task in T hours, and that T is what we are trying to find out. This would mean that A does the job in T plus A hours, whereas B does the job in T plus B hours. So combined, how much will they take? If you remember the formula from above, which we just derived, AB by A plus B, in this case it would become T plus A into T plus B divided by T plus A plus T plus B. And this is the time taken by them to finish the complete task combined, which if you see in the beginning of the question, I had assumed as T. So let's say that this is T, then what do we get? I take T plus A into T plus B to the other side. On the left hand side, I'll be left with T square plus AT plus BT plus AB. On the right hand side, on the other line, I will have T square plus AT plus another T square plus BT. As you can see, T square, 1 T square from both sides will cancel, AT will cancel, BT will cancel. What will you be left with? On the left hand side, I'll be left with AB, and on the right hand side, I'll be left with T square, which would tell me the value of T is what was given to me in the question or the statement root of AB hours. This is once again a very important formula which comes in very handy on many occasions. I'll just repeat it. A does a particular job in A hours, B does A hours more than A and B combined, B does the same job in B hours more than A and B combined. Then together they will take root AB hours to finish the job. Very similarly, let us look at what happens when 3 people are doing the same work. That is, A does it in A hours, B does it in B hours, C does it in C hours. Together they will take how much time? Instead of going the long way, let's just figure out in 1 hour how much work will they do. A does the complete task in A hours. So in 1 hour, A will do 1 by A. Similarly, B will do 1 by B. Similarly, C will do 1 by C. So together combined, they will do BC plus AC plus AB divided by ABC. This is nothing else but I have taken just the LCM here. So if in 1 hour they will do this much portion of the work, or BC plus AC by plus AB by ABCth portion of the work, then how much time are they going to take? The time they are going to take will be the reciprocal of this particular value, which comes out as ABC by ABBCCA hours. Let us take an example to illustrate this further. Say A does a particular job in 2 hours, B does the same job in 3 hours, whereas C does the same job in 6 hours. Then together, how much time will they take to complete the task? Let us figure out in 1 hour how much work will they do. Using the ideas mentioned above, or simply speaking, how much work will A do in 1 hour? A will do 1 by 2. How much will B do in 1 hour? B will do 1 by 3. How much will C do in 1 hour? C will do 1 by 6. Now, if you add 1 by 2 plus 1 by 3 plus 1 by 6, what happens? Well, your LCM of 2, 3 and 6 comes out as 6. In your numerator, you will have 3 plus 2 plus 1, and 3 plus 2 plus 1 is 6 by 6, which comes out as 1. So, they will be able to finish the entire task in 1 hour. Let us see if we can get the same value by the formula. In the numerator, I have A into B into C, that is 2 into 3 into 6. In the denominator, I will have AB plus BC plus CA, which is equal to how much? That is 2 into 3 plus BC is 3 into 6 plus CA is 2 into 6. Let's 2 into 3 into 6 is 36. And here we have 2 into 3 is 6 plus 3 into 6 is 18 plus 2 into 6 is 12, which is also 36. And as you can see, 36 by 36 is indeed 1. So they will be able to finish the task in 1 hour. As you can see, we got the same answer from calculating it and as well as from the formula. That's pretty much it, guys. Please provide feedback via Twitter at my Twitter handle Ravi Handa, or you can also email me on my mail ID, which is ravihanda@gmail.com. Thank you.